So yeah, hello. My name is Flavio Brasil, like he said, and basically today I'm gonna talk about Quill and how it works internally, so how it does things at compile time. I imagine some of you have heard about Quill already, but I will give like an overview of the library and what it does as well. So who am I? I work here at Twitter as a software engineer. I work on the core services team, and more specifically, I work with the Tweets microservice. I've been in Scala for a few years, and I really love open source. So I'm always working on something, and the last thing that I've been working on is the Quill library. And it is a compile time language integrated query. So the idea is when we are talking to services like databases or other systems, sometimes we have a target language, for instance, SQL queries or GraphQL queries, and it's not so nice to have to write another language within your host language. So Quill is a library that allows you to express queries in the host language, so leveraging Scala's syntax and also the type system, and then execute these queries against a target language. So just to give you an example, this is a very simple query. Select name and the difference of age between two people, A and B. Select from the couples table, people A, people B, and then join by the couples table, the two people, and then find all couples where A is older than B. Okay, and then return the difference of age. So it's very simple. And there is a way of expressing something very similar to this in Scala that is using for comprehension. So we can say like that couples and people are tables in memory, and then we use a for comprehension. We can get one couple, one person A, person B, apply the filtering in the for comprehension, and then use the final value. Okay, but this actually has a problem, right? If we have everything in memory, we have to load everything from the database in memory, and sometimes it's not efficient. So sometimes it makes sense to load everything in memory, but the general case is not that. So how can we would like to write a query like this because it's a single language, we are using Scala, but we don't want to write it because it's not efficient. So what can we do about that? Turns out that someone has answered this question. Okay. So if you see here, it's actually very similar. So it turns out that someone has answered this question, and Philip Wadler is a very important person for the functional programming community. So he worked with things like defining monads, defining type classes, and etc. So someone that we should know, most of us are using things that he defined. And one of his latest work is this paper that is a practical theory of language integrated query. So it's a very interesting paper. There are many talks about this that he gave in multiple events. And it basically has like the answer, how can we write this kind of query in a host language and then execute against a target language. So it shows, it gives two main techniques to support this kind of language integrated query. The first one is quotation. So this is a way of building a DSL, the quotation approach. And instead of having this as normal Scala code that would be executed at runtime, we basically quote this block of code. So it's a method call. In this case, Quill implements this method code as a macro. And what happens here, instead of this being code that will be actually executed at runtime, this code becomes a parse tree. So the macro receives a parse tree from the Scala compiler, and basically Quill will parse the tree from Scala and then generate an internal AST that is more or less this. It's not readable here, but it's actually a very simple AST, only with non-operations and things that we can translate to the target language. I will show you an example where we can read the AST. And the second thing that the paper presents is normalization rules. So it turns out that building the DSL is the easy part. The hard part is normalizing things and then generating the final SQL statement. And the paper brings like this normalization approach. That's more or less this. Don't be scared. It seems to be something complex or something like that, but it's actually very simple. If you see this transformation being implemented in Microsoft LinkU or even Slick in Scala, it's like thousands and thousands of lines of code, and this is very simple and this is very elegant. It's like less than 1,000 lines of code in Scala to implement this. And it's much more robust than normally the other solutions are. And okay, I won't be able to show all the normalization rules, but I will show one of them to you today. That is the 4-4 one. This is one of the most important ones to generate SQL queries. So the left-hand side is the pattern that we should be looking for, and the right-hand side, that is the second line, is the normalized form of that pattern. So instead of, it's hard to understand because it's using another notation. I think this is F#. And it's not possible to translate this directly to for comprehensions in Scala. The way that we can translate this to Scala is using two flat map calls. So it's P flat map to Q and then flat map to R. And the normalized form of this composition is P flat map to Q, but the second flat map becomes part of the body of the first flat map. Okay? So there's just like a parenthesis change. And it's interesting because the paper doesn't mention this. We can do this transformation because there is something in monads, that is the associativity law, that says that both versions of the composition have the same meaning. But for our transformation to SQL, the second one is easier and is a step towards the final SQL statement. And we have the AST produced via the quotation approach. We have the normalization engine based on the normalization rules and also other reduction phases. And from using these two steps, it's actually very easy to generate the final SQL statement. That is exactly the same as the one that we were trying to reproduce in Scala. So that's the overview of the library. Do you have any questions about this? Questions? Yeah.
How did your macro recognize couple is an entity?
Recognize what?
That couple is an entity.
Which one here? Sorry, empty?
So entity?
Oh, entity.
Can you mix like entities and non-entities? And how does the quote macro handle it?
Yeah, so for Quill, the entities don't need to be anything else. They can be just like a case class. They are just a case class. And the parsing will see like there is this type here that's being queried, and it will use it to say this is a source table. Any other questions? Okay. Cool. So I will show you now one example of a more complex query. This is from the TPC Age benchmark. It's a very well-known database benchmark. And this is the query number 2. So it's this big query. It's not so hard to understand, like it's just big. And we can use the same approach and just translate it to for comprehension. And it's more or less the same thing, right? You have the same structure. But with the quotations and the way that Quill does normalization, and the paper also defines the normalization, we can do something better than this. We can extract small parts of the quotation and then compose small functions. So here I have this part of the query that is actually equal to this other part. So what can we do? We just extract a function, right? So this is looking for the availability of a part given a region. So selecting from the relation between parts and suppliers, and then selecting from supplier, nation, region, doing the filtering, and then filtering by the region and the part, and then using the final value of this quotation. And then we can reuse this quotation to define another small quotation that is the minimum cost. Given a region and a part, find the availability of the part in the region, and then get the minimum cost for that part in the region. And the last one is find part. This is actually very simple, given a size and a type of part, query the part table, filtering by the condition. And here we have the final query that is much more readable, easier to understand, because we have like these small parts that we are composing. So find the part, and then find the availability, and select the one that has the minimum cost in the region, right? So this is very powerful, and basically the quotation gives you the tools that we have for normal Scala code, like composing functions, using higher order functions, and things like that, because the normalization engine will apply beta reduction and other reduction phases to normalize everything, and the final SQL statement will not have the functions. So we can abstract using functions, but the final SQL statement will not have functions. Any questions? If you have questions, you can just stop me, okay? And as you can see here, it's much more readable. And it's very nice because basically you can reuse the find part quotation to do other queries. You can reuse these small functions to do other things as well. But this approach, so this is how I implemented the paper, and this actually has two problems. So first, normalizing the queries and generating the final SQL statement is actually somewhat expensive. It's not for free. You have a price to pay. And you also have a long feedback cycle. When you are creating the quotation, it's hard to know if the quotation will produce the query that you are expecting, or the database will be able to execute the query. So I started thinking, okay, this paper is great. Could I do something to make it better? Like, could I make it in a way that the feedback loop is shorter, and also I don't have runtime overhead? And I thought, okay, I'm already using macros to do the quotation, and I ended up creating this technique that I call Dualistic quotations. Okay, so this is basically explaining how Quill works and does things at compile time. So here I have another example. We have two case classes, and then I have the quotation person by name, filtering all people with the name that's passed. And then I have a second quotation that is context by person name, that's using the first one, okay? And then finding all contexts of that person. So what happens here? When I'm using the first quotation, when I'm calling the quote method, is a macro method, and I have all the information about the quotation. I have the AST, I have everything. And I could just translate that to SQL statement, right? But there's a problem. When I have a second quotation and I have a reference to the first one that is person by name, I don't have any information about that quotation. Basically, the macro system will give me just an identifier saying, okay, there's a reference to person by name here. And I don't have any information to continue and generate the final SQL statement because I don't know what's there. And the technique that I used to implement this is basically this. When there is the quote method, it's a macro method. This is the transformed version, the output of the macro. That is an instance of the quoted type. The quoted type has the type of the quotation, and then it has a method that returns the AST. So as you can see here, the AST is very simple. It's basically a function. I'll show you I will show you again. And then this gives me access to the quotation AST at runtime, but at compile time, when I'm expanding the second quotation, I don't have access to this method. I don't have the information at compile time. And what I did was create an annotation to the method. So with this annotation that has the AST, basically Scala annotations are part of the type signature in Scala. And I'm creating a type refinement that has annotation. And once I have a reference to that quotation, I also have the access to the type of the quotation, and I can access the quotation as a compile time value. Okay? And I also have to create a method ID because Scala has some bugs with unifying types, type refinements with annotations. And basically what happens when I have the call person by name, I'm parsing the quotation, and I have all the information about the current quotation, that is context by person name, but I also have access to the AST of the person by name function. And I can splice the AST locally, and this basically propagates to the point where I actually call the quotation and execute the query, and the query generates the SQL statement. Okay, any questions about this part of the talk? No? Too much? Is it possible? Do you understand why? Okay, nice. And then, but this approach has some limitations that's important to know. So the first one is dynamic queries. So if the query has, the structure of the query changes depending on runtime values, for instance, it's possible to have bind variables that are runtime values and they are fine, they don't change the structure of the query, but there are types of queries where the structure changes. So let me show you an example here. So let's say that the person by name quotation checks if the user is admin and then return all people. If it is not admin, it will return only people that are not protected, like a visibility filtering. And what will happen here, Scala will have to infer a type for the first quotation, and it will be quoted, this upstream to the entity query, and we basically lose the type annotation, right? So for dynamic quotation, Quill doesn't have the information to continue doing things at compile time. So that's the first limitation. And the second one is, okay. And the second one is when the user does type widening. So let's say that we have a person by name, but the user gives an explicit type to the quotation, saying like quoted from string to query. So this means that we don't have the annotation anymore. We only have the type quoted, and we don't know anything about this first quotation, and we won't be able to generate the query at compile time. Okay. So that's a limitation, but yeah, that's not cool. But there's something very interesting, and I'm looking forward to be able to migrate to Scala Meta. That is, we will be able to get rid of the second limitation. So we could give explicit types to quotations. So it would be the same thing. You could use the type widening. You could say like this is a quoted from string to query, but there's this modifier here that is inline. And Scala Meta will, instead of considering the first quotation as normal Scala code, it will splice the tree, the original tree, into the expansion of the second quotation. So I will have access to the original tree of the AST instead of just an identifier. And this is very interesting. It would be possible even to support somehow like dynamic quotations if we could evaluate Scala code at compile time, but I'm not sure that it's totally possible to do, so I will play with it when I migrate to Scala Meta. And this is awesome. And it's very, do you have, sorry.
Okay. So what happens if you lose type notation? It just doesn't compile?
Oh yeah, that's a good question. If we don't have, okay. He asked what happens when Quill loses a type annotation. It will fall back to runtime query generation. Okay, so if Quill doesn't have information at compile time about the quotation, instead of applying normalization rules, query generation at compile time, it will fall back to runtime query generation. Yeah, And it's interesting because normally people think like Quill is a lot of like macros or something like that. It's actually like most of the code is about generating queries, and it's normal Scala code that's used or at compile time if the query is none at compile time, the AST. If not, it just fallbacks to the same execution but at runtime. Any other questions?
What restrictions are there for what you can do in the coded?
Restrictions in terms of operations that you can do, or?
Yeah, because at the end you kind of have to translate it to a query.
Yeah, that's true. So he asked, what kinds of restrictions we have when we are defining quotations, right? We have to, so the parser will be able to parse only things that are supported by the target language. So we will fail to compile if there is something that's not supported. And you can do like high order functions, you can do function calls, you can do most of the things that you can do in Scala, but they need to be operations that are supported by the target language. Okay. Other question? No? Okay. And it's interesting because if you think about the quotation and how it influences the way that the code will be executed, it's actually when we are defining a quotation that is static, we are doing like meta programming, the user is doing, because it's affecting how the code will be actually compiled. So I have this example here. So like I said, entities are basically case classes, normal case classes. There is no mapping code, there is nothing else, it's just a case class. And then we can define a quotation that is querying all people that have the name John. And then map the result to the age of the person. And then, please pay attention here. So at compile time, we are going to get the annotation from the quotation and then do the normalization work and then generate the final SQL statement. So this means that we have very low overhead at runtime. There's some overhead because Quill also does encoding and decoding of values and provides some abstractions to avoid resource leaking and things like that. But it's very low overhead. The query generation doesn't have any overhead at runtime. And the feedback cycle is like awesome because you can see at compile time, will it like compile or will it be valid or like is it what I'm actually expecting? And okay.
Let's say there is a set of names that you input from a forum on the UI. Can you say set dot contains p dot name and will it work?
You say like a normal contains operation?
Yeah, normal set dot contains, where
yeah.
the set is actually being inputted from a forum on a front.
Yeah, it's possible. So we don't have like support for all SQL features, but most of them are supported. So for instance, if you have a set, you can use contains. It will be translated to in clauses in SQL, for instance. Okay.
So sorry, piggybacking off of that. So can you input dynamically at runtime the values for example, if John, would it templatize?
I see. Yeah. So he asked if we can at runtime splice something, like insert something that is a runtime value. And yes, so there's a method that's called lift, and it allows you to lift a runtime value to the quotation, and in SQL it will be a bind variable, and without problems with SQL injection or something like that. Another question there.
Is there any schema generation in Quill, or is that up to some other? In other words, how do I know that person is defined that way in the database? That I can actually do that query and succeed?
So that's a good question. Right now, we don't have any tools for DDLs for generating databases, and we don't have any like management about versioning of databases or something like that. We have plans to do that, but we have a feature. I will show you it now. That is compile time query probing. So I can, for instance, change the person name age to age E, and the compilation will fail. So I configure my compilation unit to have a database connection, information for database connection, and Quill will, at compile time, talk to the database, try to prepare the query, and in this case, like the column age E is not in the database, and the query will fail to compile. Okay.
How bad is compilation time performance because of this extra addition of checking around the database?
Yeah, that's a good question. We don't have like numbers on it, and you can expect more time for compilation because you are doing more work, but the Scala compiler is already very slow, so it's possible that the time that's spent like talking to the database is much faster than like everything else that Scala compiler does. So yeah.
even if the number of queries increases, like in a typical production application, you will have a lot of queries, and
Yeah, that's a
there's
good
some
question.
kind of optimization where you keep a map of, okay, these are the entities available which should have these fields because I already queried like.
Yeah, this is something that we have to think more about, and I think we don't have, most of the users are not using this feature yet. So if we start having like a bigger code base, we have to think maybe about having like, okay, now I'm going to release, so I'm going to compile with the database connection and verify the queries. But for normal development, I could just disable the query probing or something like that. But yeah, this is something that it's more or less an open question. We have to experiment with it. Other question there.
Do the case classes the queries being directly related to the table? And if so, how do you deal with more than 22 columns?
Good question. So,
What was the question?
oh, sorry. Yeah. So he asked if the case classes need to map directly to database columns, and the second question is.
Well, if it's the case, how do you deal with more than 22 columns?
How we deal with more than 22 columns. Okay. So the first question, when we are defining the case class, we can define using any identifier, and then there is a way of defining a quotation that says, for this column, use this other name, and then you can build other quotations on top of that quotation. And there's also something that's new, and that is the meta instances that Quill has that allows you to control the way that Quill expands case classes. That is another way of maybe renaming things. And for the second question, case classes support more than 22 elements, right? They don't have an apply method, I think, in 2.11. So Quill doesn't have any limitations in terms of number of columns. So you can use as much as you want. Okay.
So coming back to this compile time database checking question, what if my database schemas are different between my production and staging environments? I will be compiling my code twice between two environments? Like, I mean, it's a little confusing.
Yeah, it's something that you have to, it's more an operation question, right? You have to choose when and how you're going to validate your queries, right? If you have a stable environment and the staging also has the most updated version that will be executing in production, you could like always have the completion warning, like the compile time query probing enabled. If not, you have to do something else, maybe enable in some environments and others not. Cool. And just to give you an overview of what we have now. So there is, we have a few modules. So there is Quill core that has a quotation, implementation, normalization engine, and all the macros. And this core is agnostic to the target language or drivers or anything like that. So we could extend this core to generate GraphQL queries, Spark SQL queries. We could generate even queries on top of Scala collections in memory in a more efficient way. So it's very extensible. And if you want to implement a new extension, feel free to come and talk to us. We are going to give you support to generate a new to create a new extension of the core. And then there is Quill SQL that has the driver agnostic SQL generation. It doesn't know anything about the actual database driver. And then there's Quill, Async, MySQL, and Postgres. They provide fully non-blocking I/O for MySQL and Postgres. This is not just a wrapper on top of blocking JDBC. There's also integration with Finagle MySQL and Finagle Postgres that is based on Finagle, also fully non-blocking. And that we also have integration with JDBC. If you don't have like a very high scale, it's fine to use JDBC, but if you have to scale your application, it's better if you could use non-blocking I/O, so use the other modules. And we also have a new module that is the Quill Cassandra one that generates another target language that generates CQL using the DataStax driver, and it also has integration with Monix for reactive streams. And we are planning to extend the reactive streams integration to the other modules as well. And that's all I have. Okay. You can follow me on Twitter and GitHub, and we are hiring. We are looking for maintainers. We don't pay any cash, so be aware of that. But my team here at Twitter is also hiring, so if you are interested, we also are hiring. And yeah, that's it. And thank you. Any other questions?
Is Quill being used in production by any of your services in Twitter?
Not my services. I don't use relational databases.
Repeat your question.
Okay. So he asked if we are using Quill at Twitter. There are some teams using. I don't use it because I don't use relational databases in my service.
Any thought about designing an extension that generates Doobie connection I/O programs?
That's a good question. So I think Rob created a module that integrates with Quill, but it's not updated. I think it doesn't work anymore, but maybe we can also integrate again. Yeah.
Could you tell something about the differences between your approach and the one used by Slick?
So he's asking about the differences between Quill and Slick. And so the way that the DSL is built is very different. So Slick uses an embedded DSL, so it's something that will be executed at runtime, and Quill uses the quotation DSL that will not execute anything at runtime, so to produce the AST. The query generation is similar, but the implementation that Slick has is not so robust, I think, because it doesn't have like a basis like a paper as this one. What else? But like it's the same space, the same abstraction as Slick. Yeah. Cool. I think no other questions. Okay. Oh, one last question. Sorry.
I can ask, what exactly is this module for MySQL and Postgres, the async one?
So he's asking what is the module for async Postgres and MySQL. It's a non-blocking I/O database driver in Scala for MySQL and Postgres.
Okay.
So it's not something that we implemented. It's not part of the Quill project. It's another driver. Cool. I think that's it. Thank you.
Thank you.